Okay, where are we here? Uh, Let me run it and see what happens. Oh, there it is. Right now, it's using just the bias layer to learn how to undo the effect of the bias layer. You start with the neural net. That's the input of the neural network, and this is the output. It's learning how to cancel out the bias in order to output the image. It's not much learning, but doing something. It's working. Okay, now we're gonna learn to add a pooling layer. There are two kinds of pooling layers: average pooling and max pooling. For the first kind, average pooling, I think we've did that before, the image thing. Okay, we just have to find out where we did the image thing before. Okay, go to definition. Where is the image? Image create, type image open. Ah, it's not opening the image. Oh, for some reason it's not doing it. Let me find it. Okay, I found it. Okay, type image. Index map copy. So we're going to use this to create a new type of layer. Okay, so we take the bias layer or the previous layer or the bias layer, and then we create a new file. New file, header file. Okay, let's just copy it, bias, everything. Okay, where are we? Where is it? There it is. Okay, new file. Nope. Wait a minute. Now I'm confusing myself. I can't see anything. Okay, new layer pooling. Is it max pooling? Pooling. Uh, I don't actually like the word pooling. So as I will, instead of calling it pooling, I'm going to call it scaling. Scaling is for max pooling. No, scaling is average pooling, and pooling layer is a max pooling. Layer scaling. That's just a personal preference. You can call it scaling or pooling. That makes no difference. But you just have to know that there's a difference between max pooling and average scaling. And if no, and the if. Let me just copy everything, because all the files have the same basic structure, so it doesn't really make sense to just try to redo everything. Okay, all right. So I just modify it. Null scaling create. So what do you need to create a scaling layer? Now we come across another problem. In order to scale, we need a source and a destination. So just saying that the layer has a width, height, and depth is not enough, because you have to know the depth of the last layer of the next layer. But because we add the layers one by one, we don't know the network doesn't know the width and height of the next layer, so we have to tell it. So let's just copy everything down here and then modify it. Is it result? No, source. Parent width. No, source width. I'm just gonna call it source, just to keep everything the same, aligned. Source depth. Result width, result height, result depth. Sometimes things just get confusing. Okay, what else do I need? Okay, type image. So we need an index map. Type index map. Index map 1. We have to modify the layer type. Why is it doing that? Okay, I'm having a slight problem here. Okay. Let's now we add the index map into the layer type. Okay, we need two indices, one for the source index map 1 and an index map 2. Why do I call it 1 and 2? Well, because the name doesn't really matter. What we need is include type index map. Type index map. Okay, index map 1 and index map 2. We don't need to call it anything special. Okay, now we need to create the index map. Okay, we don't actually need to set any of the other. Oh wait, I'm confusing myself here. What do I need to do? Oh yeah, now we have to create the index map. Neural layer scaling. I'm just cleaning things up before we get to the real stuff. That neural layer bias scaling. Okay, I'm just trying to figure out what I need to do here. Okay, type index map. What does an index map do? Go to definition. Okay, index map create. No, index map create scale. Okay, index map create scale. But the scaling part, parent, the index map 1. Parent index map 1. And parent index map 1. But now we need a width, a source, and a result. And this is where it starts to get confusing. Index map 1, source, and result. Okay. No, or okay. But first we have to assign the shapes. Type shape assign. Shape assign and result and source. Source first. Is it source or result? And source width, source height, source depth. Okay. So far it should be simple. Result. We just assign the two shapes and then we create two index maps. Result depth. Okay. We create a. Now we have to make a choice here. Is it source first or result? Okay, result. We need to copy from the source into the result. So which one comes first? Parent. Source, result, and result source. So we have to get this. We have to get this part right. I need to calculate which one comes first. Source into result. No, result comes first. That's where it gets confusing. Not layer. Index map. I know this. Now we have to reverse this. Okay, in index map 1, we are copying from the source into the result. From the parent layer into the next layer. So result width is the next layer. So in the index map 2, we are copying we are backpropagating from the result from the next layer into the parent layer. So we're doing the reverse. So far this should be right, I think. So you just have to reverse those. Make sure you get everything right because it could be problematic. Okay, this part right here we need to replace with something else. Okay, now we need to take this entire function and copy it. Because here we're doing it in an image, but now we need to do it in a new array. And it's going to get complicated. Divide index map copy. Let's just put it up here. Okay, index map copy, type neural. Okay, let's just copy the name. Type neural array, index map copy. That's a long name. Okay, type neural array, parent, type neural array, source, type index map. Now I need to copy and include an index map. Type shape, type index map. Okay, we added index map. Okay, now we need to figure out how to copy all this. Oh, are we in the right place? No, we are. A mistake. Multiply, divide. Oh, index map copy. Okay. Now let's try to do this correctly. If no parent, no if index map, if parent and source and index map equals 0 is good. If parent dot array length. Wait, no, that's not the same thing. That doesn't mean anything. No. Oh wait. My mistake. If parent dot array length. No, if parent dot array length not equal index map dot array index width. This could get confusing real quick. For I equal parent dot index map dot array length. Okay, we replace RGB. Type null unit. Type null unit. And replace RGB. Type null unit sum. Type null unit sum. We need to sum up all the values. And counter is a counter. That's normal. We don't need to average anything, so the counter can be a long value, so it doesn't really matter. Okay, color, we don't need that. Why is it having a problem? Okay, let's do everything the same. Sum equals 0. We're just copying everything as much as possible. Index map dot index width, index dot index map index data to k, index for equal invalid index. It's possible we're missing something. Oh, I just realized something here. The index map only applies to it's a 2D index map. Because I made it for image, because everything is exactly the same, it's only a 2D index map. So just making a copy of it is not going to work. So now we have to add an extra step. Okay, now is the problem. Because I'm using a 2D index map, so now I have a choice. Either make it a 3D index map, which will take a lot of space, and since we're going to be doing convolutional layers, that's going to be a huge map, because it's going to take up it's going to have to copy the same image several times. Or I could just move this into a separate function. So I'm just going to move it to a separate function. Okay, static, type image scale, type new array scale. Array scale 2D. Instead of type null array, we're gonna have to create a type null unit. Type null unit result. No, null unit pointer. Result type null unit source, no source data, and unsigned long index. No, unsigned long index map, or just copy type index map. I was going to do it a different way, but I don't have time for this. Type long index map. Okay, so instead of doing it down here, we're just going to do everything up here. Copy and cut and paste. All right. So for I equal index width, sum plus counter for j equal index map, index, check everything. Index equals source dot, no, not just source. Index equals source, not source length. I need to know the source length. Okay, source length. Unsigned long. No, unsigned long, not length. Long. Don't do it that. Unsigned long source length. I'm making it quick and dirty here. Index maps. We need to know the length of the source. That's an image thing. Source length. Okay. Color. It's not color. There's no color here. Source. Sum plus equal. Sum plus equal. No. Sum equal. No. Is it equal or no? It's sum plus equals. Not unsigned char. No. Source dot index. Sum plus equals source dot index equals source dot index. Is it the right one? No, it could be. It doesn't matter. Okay, sum plus equals source dot index. Counter plus plus. Okay, equal index width. If counter plus equal 1, sum divided by counter. Wait, no. Sum difficult counter. Yeah, we have to take the average. Go to scaling. It is scaling, not convolution. Result. Result equals sum. Result equals sum. Result dot I equals sum. Okay, do I have the source? Result dot I equals sum. Yeah, that's it. Now we just have to copy some of this stuff here. Okay, for I equals sum result. Not sure if I got it in the right order, but yeah, we just have to source length. I don't think we need to know the result length because that's gonna be the same as the index map. Index map. Okay, now we need to check everything. If not also equal, no, not parent.array length. If index map.array width not equals parent dot array shape dot array width shape width times, just copy it. I don't want to type it again. Shape width parent shape height, because we're only doing one slice at a time. Height. No one. I hate cap lock. Okay. No, height. Return 0. Okay, we are doing one slice at a time. So for each slice, for unsigned long I. For I equals 0, I less than parent. No, it's not parent, it's result. Oh, parent index map copy. No, parent source. No, source is result. Okay, that's result. Parent result. I completely forgot about that. For I equal parent dot array shape dot array depth. Okay, the depth represents the number of slices in the two-dimensional array. Each slice represents a two-dimensional image. Now we need the number of images. I plus plus. Now we need to call this function up here. Statics that neural array scale to d. Copy to d. Let's call it copy to d. Because we're just copying. It can be useful to do all sorts of operations, not just scaling. Copy to d. Now copy kernel. Copy slice. Yeah, I don't know. Copy to d. No, we have to call that 2D because we need to know that that we're passing on a 2D index map. Otherwise, you're gonna get confusing. Kernel array no array copy 2D. Gonna have to make sure this works. After that, we're gonna have to change all this because it's too dirty. Let's just make sure it works first. Index map. Is it void? Static void. Okay, that. What am I doing? We need to copy this. Kernel array index map copy 2D. Let's just change the name. Kernel array index map copy 2D. Okay, could a null unit parent dot array data. No, parent dot array data. No, data. Could a null unit next dot array data. Now is source dot array data. Array data. Index map is just index map. We're gonna have to change that later also. Source length equals source. Parent. No, it's source dot array length. Source dot array length. Oh no, it's not source dot array length. Oh, I got this wrong here. Unsigned long. Source length. Oh, it's just this right here. Normally I copy them into the different variable, but source length g dash. Confusing myself here. Source length, result length. No, parent length. I usually call it source. Result. Okay, source length. Just copy them. Source, no, parent length. What am I doing? Parent length equals this right here. Source length equals source. Okay, parent length, source length. All right. We just need to make the names clear. But now we have another problem. Because it doesn't tell us just where the slice is. Okay, parent length times parent length plus source data. Okay, now we have a problem. Parent length plus so parent length, no, parent data plus parent length times k, no, times I. So we start from the origin and then add the length for each slice at the end of each slice, and then we just do the same here. Source data equal source length. That's why I did that. Source length times I. So this equals the start of that particular slice. Parent length sign data plus, that's just a bit of pointer arithmetic, that index map source length. Okay, I should do it. Kernel array index map copy 2D, parent length source length. Let me just verify that it works. Oh, there's one more thing I need to check. If parent dot index shape array shape dot shape depth, no, what is it doing? Shape depth not equals source. I just copy this. I don't want to do this twice. Source dot parent array shape dot shape depth return 0, because they need to have the exactly same number of slices. Otherwise, things will go wrong, like a lot wrong. Okay, I'm just keep checking. For equal shape depth, and then we multiply each slice. That should do it, unless I missed something. Let's just test it and see if it works. Okay, I think it's close enough. And now let's just modify scaling to make sure that everything works the way it's supposed to. Feed forward. Let us copy it. Index map copy to D. With the parent.index map copy to D. Next.layer outputs. Parent.layer outputs. And parent.index map. And no, parent.index map 1. Is it the right name? No, it's not the time to be changing the name. Index. No, layer. Layer map 1. No. I just like to be consistent. Layer map 1. Save. Okay. Layer map 1. Layer map 2. Oh, why is that here? That's a mistake. It's and, not whatever this is. Okay, layer map 1. Layer map 2. This part just a bit confusing looking. Okay, parent.layer map 1. Next.layer result source. Just make sure everything works. Now we just copy it again. Whoa, what is that? Ah, that's not right. Why return 1? Oh, that's a mistake here. Bias. Why is it returning 1? It's return 0, not return 1. What is it doing? Return 0. Oh, we have a problem here. Oh no, okay, that's good. Okay, return 0. Oh, that's a weird problem. Okay, scaling. Index map copy again, except we do it in reverse, and we use layer map 2. What is it doing? Index layer map 2. I should really change that name. That doesn't make sense. But we don't have to check the out because they should not be the same size. They definitely shouldn't be the same size. Okay. And we don't update the weights. There's no update weight here. And then change it from bias to scaling. Scaling feed forward. Scaling backpropagate. And destroy, we don't need to destroy anything. We just call layer destroy and we're done. Return layer destroy. No. Scaling backpropagate, scaling copy. Now just have to hope that we get everything right. Let me just compile it, see if everything works. And a few little problems here. Just some housekeeping stuff. Source width. Copy everything here. I'm sure I missed something else. Let me go check. And of course here we have to put the indices, not the. We have to turn those into pointers using AND. Let me keep checking. Okay, so far it's looking good. So now let's add everything to neural network. Add layer null, just copy this, add layer bias, copy. Layers, just add layer bias, add layer scaling. But of course, we have to change everything into scaling mode. Source width, result width. So it's just going to make everything look dirtier. Okay, so it just makes everything look dirtier, but that's what we have to do in order to do scaling. Otherwise, it just won't work right at all. Okay, new add layer scaling. New layer scaling, create. Source width, result width, and all this stuff. Let's copy this here. Okay, get rid of everything here. This is not the prettiest way to do this at all. No layer scaling, create, and call that feed forward. Everything the same, everything the same, everything the same, and we change bias to. Do you remember this scaling to the type? Yeah, we did. No network scaling. No, what am I doing? Scaling, feed forward. Scaling, feed forward, everything break, everything same. Yep. Scaling. I probably made a mistake somewhere, but I'll just check to make sure that it works. No, it's scaling. We don't change anything here. Update weight, there's no update weight. Scaling doesn't need weight updates, it doesn't have any weights. And bias scaling. No, I do it again. Scaling destroy. Okay, no layer scaling destroy. Okay, now back to the source. We just need to add a scaling layer here. Okay, scaling. No, add neural network scaling. Image. Oh, what is that? Oh, yeah, because we need to. Because it's a scaling layer, we need to decide what size. 100, 100, and 3. Because it has to be the same number of slices. You can't have different number of slice of images in a pooling layer. Okay, null. No, it's scaling again. Except we reverse everything. We scale it down and it will scale it back up. We scale it down to 100, 103, and it will scale it back up. This is really ugly. We scale it back up. No, not 3.3. What am I doing? Network. Scale it back, and then what is that doing here? And then scale it back up, and then we copy it. Okay, scaling, and I don't like the way it looks, but it should do. Okay, save everything. Is everything saved? Build, rebuild. And let's see if I didn't get everything right. I just realized I never created a scaling 2D thing. I just created normal 3D scaling for images, and that's a mistake. Do I just create a separate scaling? But no. Okay, I just modify this scale 2D. Image create scale 2D. It's exactly the same, but it's missing the 3D, the third dimension. Next map create. we don't use K, and we don't use Z. And then we created that shape length result. That doesn't work. Shape length result. Next map K scale to D. We just set everything to 0. We just set the depth to 0. Other than that, it's exactly the same thing. And if you can, yeah, you just set the scale to 0 here. Okay, shape assign 0 x y 0. Scale to D. Okay, let's just add it to the top here. Just to make sure we have both of them. Index map scale to D. And then we add it into scaling. Scale to D. Depth of 1. Wait a minute, did I? Yeah. Index map 0. Okay, so we just set the index map to 0. And we just assigned everything. So I'm just going to check to see if I get anything wrong. And we'll be back. And of course I made another stupid mistake. This right here, that's just stupid. I'm doing pointer arithmetic on bytes instead of on whatever this is. I'm gonna have to copy it to fix all of this here. Yep. Okay, we need all sorts of things here. I didn't want to do this right now, but I guess we'll have to. Source length, source index. We need to know where the index starts, not just assume that it's at 0. Result length, result index. Maybe it's not necessary, but let's just include it anyway. Result length, result index. Okay, the result index is starting index of okay, let's copy this as result index. It's the starting index inside the index map. Result index plus I. It's the starting index inside the index map. And same thing for source index. Source index, not source index plus index. Everything else should be alright. Unless I made another mistake. Okay, source index map should be the same. This will need saving later. Okay, so now let's just get rid of all this. This is just stupid. Okay, source index, result index, source length. Which one comes first? Result index. Okay, result index, result length. Okay, result index is, oh, let's just go back. Source length plus I. Yeah, result length plus I. Source length plus I. And just copy this here. It's just result length plus I. Result length. Result length times I, not plus I, times I. Okay, source length times I, result length times I. Okay, I'm missing something. Okay, it's not called result length, it's called parent length. I have to standardize those names. Okay, parent length times I, result length times I. Okay, now let's see if I made another mistake. Okay, let's see if this works. And it seems to work. It shrunk the image and then grew it back up. So, but that's not really proof. So let's try something a little more extreme. 50. Let's shrink it down to 50. No, not 0.5, 50. Oh, would you like to build them? Yes. Build the image and then... Yep, it did it. It shrunk the image and grew it back up. So it works, I think. Let's shrink it down to 10. Well, 10 might be too much. 20. And see if it works. Yep, there it is. It shrinks it down and then it goes it back up. So max pooling works. Well, that's average pooling, not max pooling. Next time we're gonna do max pooling. I just call it scaling. But to get it to work, we have to do some really ugly stuff here. And the first thing we gotta do next time is clean everything up, because that looks really ugly. It's really messed up. So I'm just gonna clean everything up, and we'll come back tomorrow.